this is, let's see, Algebra 1, quarterfinal 2, test 1 through 45, review, part 2. Is that a complicated enough title for this video? Okay, or this, what we're going through. Who's Pop? Put it away. We really don't need our Chromebooks open for this, I don't think. I don't think there's going to be anything that's on there that's going to be, you know, in addition to this. Let's see, we're going to pick it up with question number 9. Okay, somebody give me a number. Okay. Let's see, 4, give me a variable. Q, I like Q, something a little different. Addition or subtraction? Subtraction, give me another number. 9. 9 halves. Oh, no, we'll keep it like this. 2-digit number. What did Abby, what did you say? 28. All right. We want to solve for Q. What do I begin by doing? Add 9 to both sides. Inverse operations, what we call the addition property of equality. We have 4Q equals what? 37. Okay, now what? Divide by 4 on both sides. Good. Okay. 9 1/4, is that what you got? Okay, 9 1/4. Or let's see, what would we get as an improper fraction? How many times does 4, actually, would it just be that? 37 over 4 doesn't reduce at all. Okay, so, you know, in a perfect world, right, if we'd gotten something just a little bit different, let's say that we had changed this up here to, let's see if we made that 29, then this down here would have been 38, right? Is 34 going to 30, does 4 go into 38 at all? No? All right, so let's make this, what's that? Yeah, I'm just trying to get us to a whole number by changing, let's see, what if we made this like 31? 31. Right? If that's 31, then this becomes 40, right? 40 divided by 4 equals 10, so, you know, we could see something like that, right? Okay, so it's just, you know, possible answers so we know what we're doing. All right, number 10. Number 10. Number 10 is a word problem. Okay? It's going to talk about going to a type of park. What kind of park would you want to go to? Amusement park, theme park. I like theme park. Okay? Kind of, give me an example of a theme park. Is that like Universal Studios or someplace like this? Is that a theme park? Kind of. Okay? All right. When you go to these places, the people that like live in like the big cities that, you know, live right around like Six Flags, amusement parks like that. If you live close by, you can get different deals on tickets, right? Right? For us, like, we would probably just pay to get in, right? And so we're just going to pay that one-time fee. But you could also get a season pass, right? Okay? Let's see. So they might have different types of season passes, right? Some different. Let's say that one of them offers a one-time fee of, you know, we'll call this Plan A. Okay, Plan A. Let's pick like a 3-digit number. What that one-time fee might be. $255. That's an expensive. $255 one time, right? Plus, let's take plus an admission fee for every time. What the cost of parking might be. What might the price of parking be? $20 plus $20 every time we park, right? So this is one time. This is every time we go, right? All right, so that's plan A. We pay $255 one time, and then every time we go, we just have to pay the parking fee of 20 bucks, okay? Plan B. Okay, plan B. Now, let's pick something that's, maybe less expensive. No, hold on. Okay, plan two. Yeah, less expensive for the one-time charge. What would you say? Maybe a one-time charge of $155. Okay, $155. Okay, one time. But the parking is more expensive. $40. Okay, $40 to park every time you go, right? All right. We want to know, let's say that Jeremy is on the plan A, right? He's on the plan A admissions plan. And Caden back here, he's on plan B admissions plan. We want to know at how many times that they would both have to go whenever their cost would be exactly the same. How would we find out? Could we write both of these into an equation, like individually? What would this first equation be? If we want to know what the cost was going to be, just let's say for even one time, or just every time we went. Okay, 255 plus 20p, that's correct. I'm going to write it as 20p plus 255, right? That way it looks like a slope-intercept form of the equation. Does that work for you guys? Okay, what about this equation over here? 40p plus 155, very good. All right, now we want to know, when are they going to have the same cost? Well, what variable represents cost in those equations? No? P represents the number of times we go. Y represents the cost, right? Because if I go twice, right, that's 20 times 2 plus 255. That's my total cost, right? If I go 2 times. So what are we going to do with these two equations that we've written? In order to find out when they're going to be equal. Well, I have two separate equations, so what do I really need to do, Clayton? Make both equations one equation? Yeah, we do. What are they both equal to? Y. So what we're saying is that I could substitute one equation for the y variable in the other equation, right? Because they both equal y. So what new equation could I write? Not y equals, remember we're substituting for y. No? We're substituting for y. All right, so do you see how over here y equals 40p plus 155? Y equals that. Could I substitute that in for this y? Yes? Okay, so how would I rewrite the equation then? Go ahead. Okay, all right. Because we wanted to know when they would be equal anyway, right? All right, let's go from here. What do? I want to solve for what? P. We want to solve for P because P represents the number of trips, right? It doesn't represent parking, it represents the number of times I go. Okay, so you might want to pick a different variable that you're not going to get confused with. All right, you could use T for times or trips. Okay, so, sorry, I already forgot what somebody said I should do next. What should I do next? Subtract 155 from both sides. Okay, subtract 155 from both sides. Okay, now what? 40p equals 20p plus 100. Okay, now what? Subtract 20p from both sides. Let's get our variables together, right? All right, so what do I have now? 20p equals 100. Now somebody besides Jeremy. Divide by 20, okay? So how many times would we have to go for them to have paid the same price? All right, so at the moment that each of them has gone 5 times, right, their cost is the same. So we would say 5 trips. Does that make sense? So we take the information that they give us, we write an equation. We take the other information they give us, we write another equation, then we set those two equations equal to each other and solve. Does that work? Okay. Now, if we wanted to, we could go back into this and say, at that point, at 5 trips, what was their cost, right? We could make the question a little bit more complicated, at which time I would take 5 and substitute it in. What's 4 times 5? 20, right? 20 plus 155? 175. So by the time they've gone, each of them 5 times, they've paid $175. Now, after that, one's going to go up, higher than the other or whatever. One's going to become less costly. All right. 11. 11 is going to give you a stem and leaf plot. You guys familiar with stem and leaves? Okay. It's going to give you a stem and leaf plot, and you're going to be asked to list the data from the set in numerical order. So, if I have 2, 3, 7, 9, 3, 2, 4, 5, 1, 6, 8, 7, 2, 3, and 8, 0. Okay, and I want to list this in numerical order. How am I going to do that? What's that going to look like? 32, Do you guys agree? Does anybody not understand? Don't understand. Okay. So the stems represent the tens value. The leaves represent the ones value. So notice that you had 23. That's 2, 3. And then 2, 7. And then 2, 9. Okay? Then we come down. 3, 2. 3, 4. 5, 1. 5, 6. 5, 8. Or 51, 56, 58. 72, 73, and 80. Does that make sense now? This should be maybe one of the easiest questions on the test, but if you're not familiar with stem and leaf plots, it doesn't matter, right? It doesn't matter how easy it can be if we don't get it. Does everybody understand now? Okay. All right. Did I need to go back to that? No? All right, give me a second. All right, question number 12 is going to give us 2 triangles. Okay, let's clean that up a little bit. Let's see, we're going to have D, E, F, H, I, J. All right, somebody give me a single digit number. Okay, I think I heard 3. Okay. Let's get another number. 7. Okay. And another number. 8. Okay. All right. Our question is, let's put this into feet. All right. And our question is, what is this length? What do I do? You can do a proportion. Okay, so a proportion is one ratio equal to another ratio. Abby? What say that again? T over 3? Are you saying this is T? Okay, so I mean, I guess if you're looking at it like this, I had it drawn as an X, but let's leave it as an X. So you said X over 3? Okay, it's fine. Equals what? 8 over 7. Good, that'll work. Okay, there's a number of different ways that we could write off this ratio. We could have said 3 over X equals 7 over 8. It would have been the same thing. We could have said 3 over 7 equals X over 8, right? All right, so let's just look at this. So we are going to do what now that we have a proportion? Somebody besides Jeremy, somebody besides Abby. Tiffany, cross multiply and then what? And then divide. Okay, so cross multiply. What am I multiplying? 8 and 3, cross multiply. What's 8 times 3? 24 equals what? 7x. Okay. Okay, now what? Divide by 7 on both sides. What's 24 divided by 7? What is it? 3.428. Okay, and because we made up the numbers ourselves, right, we can understand why we didn't get a nice, neat, even number, right? What you want to make sure that you do is this says we're going to answer this to the nearest hundredth. So what is our answer actually going to be written in the test as? To the nearest hundredth. What decimal place is to the hundredth? 2 over. So what is our answer? 3.43, because that 8's going to make me round up, right? And because the question is going to say make sure that you label, because if you don't label it, you're going to get it wrong. What's our label here? Feet, right? So, next to this question, I might want to, exclamation point, label, right? Because how frustrating would it be to do everything right, get the right number, and then not get credit for it because I didn't label, okay? Easy enough, hopefully. All right, 13. Okay. That's a good question. We'll look at a couple of different possibilities. Let's say that this is, negative 2, 3. The slope of that line, is it going to be, let's say that this is 1, 1. Is the slope of that line going to be positive or negative? Negative. Okay. And the slope of this line? Positive. What about the slope of this line? Positive or negative? I hear a positive. I hear a negative. The slope of this is 0. 0 slope. Is 0 positive or negative? It's not. If anything, I guess you would list it as positive, but it's really not. Okay? I don't know if you guys are familiar with this line. Does anybody know what slope of that line is? It's undefined. because it's going up as much as it's going down. So we also can't say if this is positive or negative. Okay? But your question on the test is going to be more based around whether or not it's a red line or a blue line, meaning is it positive or negative. They're not going to really try to trip you up with horizontal or vertical lines. I just want to go back over that and make sure that you understand. All right, are we good here? Okay, so we can identify positive and negative slopes. Good. Okay, 14. All right, let's say we've got another coordinate plane. Let's say this is negative 2, 4, and this is, let's say 2, 1, right? And it wants to know what is the slope of the line. Is there any way of finding out what the slope of a line is? Rise over run, sure. Yep, slope is rise over run. Y2 minus Y1, good. Where? Okay, divided by X2 minus X1. Good, yes, that is the formula that we want to use to solve this question. The question then becomes, what is Y2? Anybody besides Jeremy know what Y2 is? Abby? 1? Good. This one, right? 1. 1 minus, what is Y1? 4. Okay, divided by, what is X2? 2 minus negative 2. Okay, do I need both those negatives there? Yeah, I got to have both those negatives there. Just because it's subtraction here doesn't mean I don't have to include a negative value. Okay, what is 1 minus 4? Negative 3. What is 2 minus negative 2? 4. So my slope is negative 3 over 4. Okay? Now, if I'm going to put this kind of answer in a test, I'm going to have negative 3 division bar 4. Okay? That's how I would put that in with no spaces. Okay? All right. And actually, this is 13. This should have been listed as 13B. Okay, so you got more than one thing there for 13. Let's go into 14. 14 is going to give me coordinates like negative 4, 6, and let's see, 8, negative 2. And say, what is the slope that passes through, the slope of the line that passes through those 2 points? Is this any different than the last question? No. I still have to use the same formula. What was that formula again, somebody besides Jeremy? Good. All right. Let's see, somebody besides Jeremy and Abby that can tell me what Y2 is in this situation. Negative 2, good. Minus what? Negative 2 minus 6 over 8 minus negative 4, okay. What's negative 2 minus 6? I hear a couple of different answers here. I heard negative 4 and I heard negative 8. What is it? Negative 8. Negative 2 minus 6. Okay, imagine a number line, because I think some of you kind of still struggle with some of this. If I'm at, here's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. If I am here and I want to continue going 6 to the left, that's going to bring me to negative 8 here. Does that make sense? Okay, some of you need to get better with adding and subtracting negative numbers. All right, what about 8 minus negative 4? What is that? 12? Good. Okay, that's 8 plus 4 is 12. But I want to simplify it anytime I can. Negative 2 over 3. All right, we're going to divide both those numbers by what? 4. Negative 8 divided by 4 is negative 2. 12 divided by 4 is 3. My answer is negative 2 divided by 3 is what's going to go in there. Okay? Okay. 15. Let's see. Give me a single digit. 2, negative 2. Okay, give me a variable. X, give me another variable. Y, give me a single digit number. 3, give me another single digit number. 5. Okay, we want to simplify. We want all of the parts. What do I do first? Distribute the 5. Okay, and by that, could we expand this a little bit? So could I write that as negative 2 to the 5th, and then x to the 5th, and then y cubed to the 5th? Do we understand this maybe a little bit better? Okay, what's negative 2 to the 5th? That is the same as negative 2 times what? Negative 2 times negative 2 times negative 2 times, do I keep going? Or am I done? All right. So this might be an easier way to understand negative 2 to the 5th. What's negative 2 times negative 2? 4. What's negative 2 times negative 2? 4. Right? And then just negative 2 down here, right? What's 4 times 4? 16. What's 16 times negative 2? Negative 32. So do we understand that negative 2 to the 5th is going to be negative 32? Okay? So we got negative 32 over here. What's x to the 5th? X to the 5th. Okay? What about y cubed to the 5th? Y to the 15th. That's absolutely right, because when I have an exponent taken to an exponent, I multiply exponents, right? Okay. So do we understand how to get negative 32, x to the 5th, y to the 15th? How is it that I only got x to the 5th? What was the exponent to x? 1. And what's 1 times 5? 5. Okay, so it wasn't 6 or something like that. All right, we understand that, and we need all the parts to our answer. So this is going to be multi-select. So what you're going to look for is you're going to look for a negative 32, right? And you're going to check that box. You're going to look for an x to the 5th and check that box. You're going to look for a y to the 15th and check that box. Does that make sense? And there's going to be a whole bunch of other numbers and variables with different exponents listed in there. Those are the 3 that we want to check the box on. Does that make sense? All right. 16, I think. All right. Here we want to find the greatest common factor of the polynomial. We're going to use the caret symbol to tell the next value is an exponent as needed. So whenever we go to type this in, do you guys understand the caret symbol at all? Okay. All right, so let's see. Let's try to pick, let's say like 15. Give me a variable. Z. Okay, 15z to the, let's say 5 plus 5z to the, let's go 4th minus 20 z cubed. Okay, we want to find the greatest common factor of this polynomial. Where should I look first? The numbers, the coefficients, right? All right, so what is the greatest common factor of 15, 5, and negative 20? 5. Good. 5 is the biggest number that can go into all three, right? What is the biggest z value that can go into all three? Z cubed, right? Because a 3 can fit into all of those, right? Z cubed can fit into z to the fourth and z to the fifth and z cubed. All right, so 5z cubed is my answer. So the way I'm going to type this in is I'm going to go 5z caret 3. That's how it's going to get typed. Okay, can we do that? All right, let me double check. All right. 17. Okay. Determine the values for which the expression is undefined. Okay. Let's see. Give me a number. 12. Give me a variable. B. Okay. Operation, plus or minus? Minus. Okay. Give me another number. 36. Okay. Give me another number. 8. Operation, plus or minus? Okay, I heard a plus. Okay, another number. 42. All right, so this wants to know for what value of b will make this expression undefined. All right, what would make any division question undefined? A zero where? In the denominator, right? So how could I figure out what that number is going to be? Do I need to do anything with the numerator here? No? What about the denominator? How would I be able to find out what value for b is going to cause the denominator to equal 0? Could I set the denominator equal to 0 and solve it? No? We could just stare at it for a second. What do you think? Okay, so I want something like this. All right, what do I put on the other side? The denominator. What's my denominator? 8b plus 42. We're saying 8b plus 42 can't equal 0, but I really want to know what value of b it can't be. Does that make sense? So what do I start by doing? All right, I subtract 42. Okay. And for sake of simplicity, could I make this number, just for the sake of simplifying it, could I make this number 40? Okay, let's just make it 40 for now. Okay, so we're going to subtract 40. Okay, so 8b cannot equal negative 40. Is that as close as I can get? No, what else can I do? Divide by 8 on both sides. So what is it that b cannot equal? Negative 5. Okay, b cannot equal negative 5. But what we're going to go ahead and say whenever we put this in is we're going to say b equals 5 because that's the value that makes it undefined. Does that make sense? So we're going to write in there b equals 5. All right, 18. Okay. Ooh, all right. All right, so the distance between here, where we are, the distance between the sun and Pluto. Okay, we would need like a really, really big number, right? What would we estimate it to be, let's say, in miles? Let's make a really, somebody give me a number. let's say 3. Give me another number. 54. Okay, another number. 600. Okay. Let's say it was, what is that, 3,540,600,000. Okay, that ought to work. We want to write this number in scientific notation. How do I do that? Okay, so our current decimal place is right here, Tiffany says, and we need to move it to the left, right? Correct? Sorry. Say right, meaning correct, but then it gets confusing with left and right. Okay, so we're moving it to the left. Is that enough? Again. And I'm going to keep going until I have what? Until the 3 and the 5. So, all right, I got 3.54. 6 times 10 to the what? Is it am I subtracting or am I adding? Adding, okay. So what number am I putting? 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm told. Do we like that? No? And we would probably, let's see, I want to double check. Actually, no, we're going to include until we get to the 6th. Okay? Yep. Because 6 is a significant digit, we're going to go all the way to there. Does that make sense? Okay? Do we understand how we got 9? Okay, we understand that as we go left, we add. If we went back to the right, we would subtract. Okay? All right. 19. All right. So we're going to go to the state fair. We're going to ride the bumper cars. So there's got several bumper cars there. They have, let's see, 1, 2, we got 3. We got 3 colors. What colors do we like? Blue, red, and camo. Okay, how many blue cars do we have? 3 blue cars. How many red cars do we have? 10. 10 red cars. How many camo cars do we have, Blayton? 8. 8 camo cars. Cool. Okay. Let's see. Blayton is the first in line for the ride, and he's assigned a car at random. After him, I don't know, Blayton, who's after you in line? Who? Jeremy's after Blayton. Is that okay with you, Blayton? You let Jeremy stand behind you? Okay. So Jeremy's behind Blayton in line, and he's assigned a car at random. What's the probability that both Blayton and Jeremy, I don't know, Jeremy, what kind of car are you hoping that you get? Okay, you're hoping you get a blue car? All right. But we'll let Blayton pick. Blayton, what kind of car do you want? You want the camo car? All right. So we want to know what's the probability that Blayton is going to get the car he wants and Jeremy's going to get the car that he doesn't want. They're both going to get camo cars. What's the probability of that? And we want our answer to the nearest 10th. How would we find out? What's the probability of Blayton getting a camo car? 8 out of 21. Okay. Probability of the desired over the total, right? All right. What's the probability of Jeremy getting a camo car? 7 out of 20. And you guys do know that we multiply those ratios, right? All right. So we know we're going to get like 56 over, I don't know, what is 21 times 20? That'd be like 420. Okay, but we want our answer as a decimal to the nearest 10th. So what's 56 divided by 420? 0.133. Oh, repeating. So as a decimal to the nearest tenth, it's 0.13. No, but just to the tenth. So it should just be what? 0.1, right? Because that's to the tenth. All right, so we have a 0.1 probability. Okay, do we understand that? Now we want, we want our answer as a percent. So we're just going to say that as, hold on, to the nearest 10. So you said 0.1333, going on. So can I go ahead and change that to a percent? What is that as a percent? What is that as a percent? 13.3%. Okay, because we want the percent to the nearest tenth. Okay, does that make sense? Okay. Now, the only question we haven't done is number 20. Okay, now what this is going to be and what you need to look up on number 20 is the arithmetic sequence. Okay, this one I'm going to leave you on your own for. Okay. And you need to know how to find, I'm just going to warn you, they're going to give you a list of numbers. They're going to give you 4 numbers. They're going to ask you, what is the 212th term in the sequence? Okay, can you guys look that up? There should be an equation for it. Okay, and that's it. We're done. All right, you guys have 2 videos to watch to review for your quarterfinal. I think that you guys have enough information. If you will study, you guys should be able to ace this thing. All right, we'll stop there.